What's cracking, y'all? All right, so I handled some things off camera that we're gonna be taking a look at, and I'll explain the reason why I did everything, and then we'll knock out some of the uh, minor details that are gonna play a big part in this thing fitting in the body real nice. So let's go over there and look at it. All right. So this is where we last left off at. Um, One thing I did add in that you all didn't get to see was this servo. So after doing some measurements on my own, I decided to put a servo in here just so I can get more precise fitment. So after I got this servo in here, I realized that with the flat arm, with this swing arm here, we were running into an issue with the servo, right? And not just the servo, but we would have been running into a greater issue with the servo horn, which is going to connect to the to the spring. So after looking at that, looking at um, the messing around with the and trying to adjust the height um, for full ride, I decided to reach into my tool bag and pull out some tricks. That's the only thing I can say to describe it. Um, and came up with the idea to either round this off, which would make printing a lot more difficult. So we didn't want to go that route. Um, my second option was to bend it, break it off at a 45-degree angle, and leave some space for it to clear the servo horn. And so that's what we went with. So this flat plate, it just went away, right? So we got rid of it. I redesigned it with a 45-degree bend. Um, Also, we cut straight down the center here at that 45-degree angle. So when it's fully extended, it won't come in contact with the spring. And you all will see that on my bill. So what I did, and how I came to this conclusion was um, I did a test print. Okay. And sometimes I get a test print in halfway through my designs just so I can get hands on it and feel a tangible product and see how those gaps fit in, like the minor things like having a space in between the where the hinges are so that it doesn't bind, stuff like that, small stuff. But also you get to see parts of how it go together that you can't really tell if it's gonna work on the CAD software unless you utilize like some rendering techniques that take up a lot of memory on your computer and sometimes could cause it to crash. Um, which is why I know I mentioned it before about showing you all how to hinge these items so that they can articulate inside the software. Well, it takes a toll on your GPS or GPU, and you can start having problems with your software not running properly or whatever, trying to do those techniques. I mean, for me, it's easier to just print it out and put it together, see how it looks, see how it feels, and then make my adjustments that way. So a couple of things that I want to do now that I know this works. And the reason why I know this works is because I made a product. I made the actual product, right? I put the first step of approval on it. Uh, this is what I did off camera. You know, did a couple of measurements and a couple of diagnostics on how this is going to work mechanically, and because it looks good as a still picture, but when you finally see all the parts moving together and how much space you got left, at full extension or fully compressed, you start making more adjustments to your designs. So one of those things is moving this servo over 0.22 inches, right? And the reason we're going to do that is because it's going to allow the servo horn to sit right above this bin, and also is going to open up space for the spring to be more upright instead of candid. Okay, so that is one thing that I want to do today. All of these holes are going to get moved over 0.22. Also is going to free up space for us to create the other side of this bracket here that's going to hold this side together, the front side together. Now my idea is to create like a C channel where there's a stick that comes and holds these two parts. It wraps around this middle area here, and then it comes around the backside, and then the screw will go through all three of those parts. Same difference for up here. Screw will go through these three parts. Um, and this being the center of the whole thing, um, that center part can be linked into the bottom portion of this servo mount, and we'll have screws to tie that down as well from the top. So there, and the reason why we're breaking it apart like this is just so that we can print it easily. Now it wouldn't be a problem to um, have this all as one piece. It's just that it would take longer to print. It would take more material to print. Um, but if we break these parts down to where they're flat, we can get them to print better. And also we can have the stability of choosing um, how the part is printed, like how the layers lay on the part. And that's what makes the greatest difference with trying to make sure that certain parts are strong um, when forces apply to them in certain directions. All right, so the first thing I want to do is I want to come around here, and I'm going to extend out that edge that I was talking about. This is going to be the first thing that's going to um, mark that 0.22 that we're gonna change up as far as the servo being a little farther over. 0.22 is what we're working with. 0.22 is really good space here. That's gonna still have a lot of play with it. Like if we look at our body, how far we are from those edges, we have so much room to play with around in this area. And we're not even going to touch any of that area really. Um, the goal was to get these wheels to tuck in here nicely. Um, we actually have a really good tuck. And could possibly push to move out. Um, push to move out further. I mean, we capped it off at 6 inch width as far as the wheelbase, but I don't know. We might be able to get another centimeter of space out of this, and that's if we squeeze. But that'll come down to the wire later on. What we want to do with that. So from there, I start looking at all of this space we had, and it just made sense to push this out to the left of the vehicle, have more space here for that plate to wrap around there. The blue line is the center of the body, so pretty much this would separate, um, be separated by that line down the center of the vehicle, um, and preferably giving us a thickness of zero point 0.3 or 0.35. Just something to give us a little bit of sturdiness for that bend to happen. Nothing big, nothing fancy, but just something to give us that strength. So this here is going to get moved over, right? It's going to be negative 0.22. Also, you can move features. And how do you move features is the same way. You have to select all of these surfaces, not the edges, but the surfaces. So that one, that, and that would be one portion to move. That, 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 and down to the bottom side. There, and there, and there. And it might make us move them one at a time. Oh no, we actually got it. But since it gave us that catty corner mess, we gotta get us a new pivot point. How we get a new pivot point is by clicking on one of those circles. And now we can move it. Our 0.22 should line up with those holes on the servo just right. Also, we're gonna move that wall that was next to the servo. We're gonna move that over as well. So this is gonna free up a lot of space. And I probably wouldn't have gotten um, to this logic if I never printed those parts out. But because I was able to print them out and look at them from a different aspect, it made a lot more difference. So we got a couple of things that we're gonna have to fix over there with that move happening. Not sure what happened there. Let's take a look. Oh yeah. I forgot about that backside. So that's what happened. So let's go back real quick. So the servo has the slot for the back. So the servo could fit down in there. I forgot about that portion. So we'll just have to select all of that when we get around there to that side. So we gotta do it again. There. We can actually do all of these at the same time. And sometimes it won't let you do all of them at the same time. But I mean, sometimes you get lucky and the software is on your side and working for you. And the thing is just that when you're doing this, you just have to make sure you select the surfaces and not the lines. Because if you do that, it will not let you move. It will not let you move the parts. There. Hit that done button, hit that arrow, and 0.22 should give us that move. There we go. Now it's thinking. But yeah, if I did any kind of fancy graphics inside of the software at this point, we would really be lagging and waiting for this thing to catch up. And um, I'm not a fan of sitting through it, you know, waiting for the software to render could sometimes take 15 minutes. You'll be sitting still for 15 minutes just looking at the screen. Negative 0.22 puts us right where we want to be. There we go. Now let's swing or swivel back around to this side here. The only thing that's not moving is those holes for those swing arms because we don't want to shorten those up. So that's the reason why that's going to stay. Other than that, this mount that's going to happen, we could bring them low so that we don't have to mount into the hole. That could be an option. At this point, wherever we mount that would not be, it would not hinder the mechanics of the swing arm and stuff like that, because it's not even gonna get close to where the spring and the swing arms operate. But we're just gonna see what type of design we can come up with. Let's see here. So let's draw. We're gonna draw right off of the face of these arms here. Just something real basic. We'll start out with those circles. You know, try to get those circles up there. Get that one there. And see if we can get a projection on this one as well. Let's see. We're gonna have to get rid of this impression too, because we're gonna end up turning this into a brass insert hole. And so we'll do that because there's not going to be a screw here now. We're going to be utilizing our plate here that we're going to make to get that hole just right. All right, so let's draw in some circles based off of that center point there. We can get us, I think it's 0.13 there to start off with, and then 0.13 down here to start. And of course, we don't have any reference here to. All right, so we're just gonna hit the P button and project that edge there. That's gonna be the only way that we can get that circle started, okay? Now we can get us a good circle. There we go. Once you have a good circle, you can get rid of that other circle if if it's too much for you, you can always get rid of it. Sometimes it complicates how these things come together. Okay, so we got that. We got that circle. We got that circle. Next thing I want to do is create the outer portion, which is at a 0.23. This is that the countersink hole, 0.23. All right, so we got our holes. Now from here is going to be from the center line here. We're going to cover a line up for these holes here. And probably just do another 2 circles that extend out a little bit past what we see here. Maybe on a 0.35, let's say 0.35 for top and bottom. This is just going to give us a good surface around the around those holes. 0.35. This also gives us something to draw off of as well. So let's see. Let's draw some center lines. And the reason we draw this center line up is so that we can get a, a square line right off of that circle there on the edges. If we did it any other way, we'll kind of be struggling to find that and link it back to the center line. But we don't have to when we do it this way. Uh-oh. I could have got that one a little further. But see how we can find that edge. Yeah, I'm gonna go past it. And we draw that line there. So now we got that. We can draw a line here and get our center point there. So now we have this bracket here that is going to line up on the outer structure. We can have it pressed down the middle. The spacing between the middle surface would pretty much act as stability for the left and versus right connection here that we're going to have. So we'll extrude this out, say 0.2, and then that bend is where the meat will be at. We'll have it rounded a little bit in the inner chamber area, and then it'll wrap around the backside there as well. That'd be how we do that. We actually can do a double extrude where we extrude both directions that full distance and then come back and extrude it again and cut out the center area. So that might be how I handle this. That might be a more logical way, a faster way to do it. So let's finish this drawing up here. We'll go here, hit that, and pretty much we can close all of these down for a second, so that we can get a look at what we're looking at and see what we see, know what we see. Sometimes you can have too many things open and it will interfere with you being able to select things. But you just have to be patient with it and trust your judgment when you're designing. If it don't look right, you can always double check or come back to it. All right, so this is the area that we're going to extrude. We want 0.2. So what we'll do is we'll do a double-sided extrude, 2 sides. This side here is going to extend out 0.2, right? A 0.2. I'm going to extend out that way. I got this I had that arrow. I know y'all saw that. I have this arrow selected and it still goes and pushes the other side. That makes sense. All right, but this for this side, we'll select that side there, and then from there, we'll add 0.2 to it. So that's going to be 1.76. Come on. Come on, man. Okay, so we see there's a little outer structure there. Now what it's trying to do is cut out this area here. We don't want to do that. We're just going to select a new body and it's going to create on top of it, but it's not going to join them together. So we do that like just like that. This whole time we're just drawing and measuring out for this one side because it's going to be mirrored. Everything we do on this side is going to be mirrored onto the other side. All right. So now we have this inner stuff here going on here. We're going to go back into our drawing. That's what I should have did. Go back to the sketch. Right, edit the sketch. We can split the difference of what would be a 0.2 or 0.3. Measure out from that side. Let's see, we would have, I kind of want to see the other side of this. Well, I can't actually see. Let's go to the top view for a second. I want to see exactly where I won't be able to see it until I actually cut it. But what I was looking to see was where that servo or the swing arm mount holes are in reference to what I'm gonna do with this piece. Here, let me come back in and undo that. Delete that. All right, let's take the visual of that part away. See, this is what we want to look at. Now, I don't want to get too close to this edge because this servo horn comes out here around this area here, and then the spring sticks out a little bit around that area. So when it bottoms out, it comes all the way flat here. There's a slight overhang here. And we don't want this mount to be right up on that servo horn. We want to be able to give it some space to breathe. So 0.2, if we did a 0.2, this piece would end up being a 0.4, which would be the same thickness as the frame. I don't think we need to be that robust. So I'm thinking we go like a 0.15. 0.15 should be good enough for us to get that nice, get us a nice distance in there. All right, and now we can finish this out. We'll open that sketch back up. We want to close the servo mount. We're going to bring that other new body that we picked up. Well, hold on, let's select our area first. So this whole area is going to get cut open. So we're going to select all of these areas. Sometimes if you're not close enough to it, it won't select the areas that you're trying to do. There. Now we got that. We're going to bring that body back and we're going to cut inward. Now, extrude that across. We can come this way with it. We can bring that servo mount back and we can click onto the outer side of that body there. But after we do that, we have to make sure that we turn it back off, or we're going to cut that piece out of the servo mount as well. We don't want to do that. We just want to cut off it into this. So we cut that loose. We're also going to give it some space too. So it'll have some play in between mount. We don't want it to be an exact match. And sandwich the parts too tight, because then that's just going to build friction. So now we can get fancy at this point with this. It doesn't have to be a solid, structure. We can cut some shapes into it, maybe a circle or something. If you all are trying to, minimize your filament usage, the whole thing doesn't have to be present. I'll probably just cut out the center areas here to open up space to be able to see the mechanisms moving around. But this inner area here, we'll fill it those so we can build that structure there. But we're gonna push outward first. Gonna push these out 0.005, just to give us that wiggle room for mounting. So let's push negative 0.05. Gives us a nice little 0.1 to work with. Preferably, a 0.5 might be a bit much, but let's double check what that looks like. Yeah, see, that was a little too much. So we want 0.005. There we go. We want just a slight gap in there. It's fine. And you're going to do it for the other side as well. This just gives you that space to play around with. This is kind of what I do towards the end of my designing. I go back in and I make these 0.005s or 0.001, and create a little gap in between all of the pieces so that they can go together and possibly be able to use some spacers or whatever, or washers in between the parts. So all right, we got that together. We don't have enough thickness to countersink these, so I wouldn't worry about countersinking at this point. Or 0.19 is a bit shallow. We can go 0.2, but we don't want it to be too thick. We just want it to hold the swing arms. That's all this is for. We don't need it to be overly, designed. Out here, there's nothing, unless you really are trying to be meticulous about using shorter screws or something like that. Countersinking those holes might make a difference at that point. But outside of that, we would. Ooh, excuse me. I'm gonna come in here and round those edges out by a 0.5. Now rounding these edges helps you to build stability for those 90-degree angles. 0.5 will get the trick done all the time. If you need an even more sturdier bend, you can go 0.1. 0.1 is good also. It just depends on how much space you need in between those areas, and whatever your part is doing. So just like we did here, we're gonna end up doing the same thing for what part was it? There was a part that needed that done to it, but I cannot remember. I believe maybe it was this part here. Yeah, it was this part before we did that adjustment. So since we did that adjustment, the frame is still gonna lay this way. We could possibly create this side to be the frame side, and then the outer side, which is going to be oh, let's pull the frame up. Let's look at this. Where is it? Yeah. All right. So now the frame sits right where that servo is. That's something that we gotta catch, and it was on my mind to catch it, so we caught it. We have that, but we can also cut. Oh, hold on, we can move this out. Let's move it out for a second. By a 0.20. Or never mind, that we gotta do the whole thing by a 0.2. And then also we got that other side. Let's get rid of that. We're going to push these surfaces. Let's push this side first. That 0.2. Right. And then come back and push the other side. All right, now this frees our space up again. Now what I was talking about before was creating that rounded lip here. Now the thing is, if we round this portion out for the 0.5 to gather that structure, we're gonna have to do the same thing to the other beam as well. So we say we round that out to a 0.5, right? It won't fit if we leave that other frame at the 90-degree angle. So we have to go in there and round that one as well by that 0.5 or even a 0.6, just to give it that clearance, 0.75 of it, 5 of them. So by doing that, we leave a little space for this to fit, and it's not going to be fighting, for placement. But also it gives it that sturdiness that it needs so it doesn't break under pressure. So we're in there. It looks pretty good. We got a little mount going on there. This mount will be split down the middle. So essentially it'll have another side to it. The swing arms, to bring those back, we got the knuckle too. We got a swing arm too. It should have some space in between from what we did. Yep, we got our space in between there. We've already created some space on this side. Or did we? I don't think we did. Maybe we didn't. All right, so that's something to think about and look at. Yeah, I don't think I did. So then we'll just press that inward. Negative 0.005. Right? Just shrinks it a little bit to get it out of the way. So these parts, they don't actually bind and touch the servo like how you see here, because I did my test fit. Yep. All right. And we got all of our leeway. This thing, it fits together pretty good. The struggle before was just trying to figure out how we were going to put this portion together and just make it functional, you know? And that's all we really wanted to do, was just come in and make it functional. Again, if you need to cut any of this back just so you can save on, you know, filament, you know, you can do it. Let's see. I'll have to cut more of that back. Let's see. We can go here, get this open here. We can go ahead and start us a new drawing on top of that. We can go back to the circle thing we had going on here. 0.35 there. And 0.35 right there. We can bring this in, curve it around here to where we get a nice little cutout right there in this area. I can see that being a good way to do it. We can go from corner to corner here. Oh, there's a circle. Let's undo this circle. Thought I had a line for a second. So we take it from corner to corner. All right. Let's see how we want to do this. Let's get a center line going from here to here. Find the center line of this. Okay. Trying to think of a cool way to draw up these circles. let's see. Because we got that meat on that side. So we want to leave quite a lip there. We don't want to interfere with that lip or that fillet that we have. All right, so this is what we can do. So we'll round it in. So let's take this here. There. Doing the wrong side here. That's that curve space there. Keep that open, yeah. All right, so what it did, it drew a curvy line, which we did not want to do. We didn't want to do that. So now it's drawing lines from one surface to the next. That's not what we're trying to do. All right. All right. I could have did it like this a long time ago. I don't know what's slowing me down mentally thinking about this, but it happens. Sometimes I just run into a lot of overthinking that gets you all that all that designing, and we still didn't get it to close as a shape. All right, let's go back and see what happened here. This whole thing here should have been a shape. There, there, around here. Let's cut that. Maybe that could have been it. So I don't know what's open. Mm, I'm not sure what's happening here. Let me see. Let me get rid of these things here. I am not sure exactly why. I'm not getting. So it seems as if there's multiple circles that it's trying to attach itself to. I think that's what's going on here. Let me see. Yeah, we should be able to cut that away. That away. All we're trying to do is cut this out. That's all we want to do. Even more simpler way I could have just did this, man. And I just, I don't know. Sometimes I don't be thinking straight. But I could have just pulled it out here like this. Got my square. Finished it out. I'm sorry for wasting y'all time with all of this. Screwed it out. Cut right through. I could have did that a long time ago. But it's just sometimes the brain is not thinking at that capacity. And for whatever reason, it is what it is. Select these edges here. Mm, yep. And get the fillet on that thing. Now round it out. There. I don't know why that was so hard to do. I just don't know where the disconnect was in my brain. But that'll put us where we need to be. I think that we are set for this front side. We can get rid of that. This here, we can pull this back out so it doesn't affect anything. Come on. There we go. So this one and that bottom, the bottom one as well. Where is it? Bottoms one now. Both of them. 0.13. All right, we got them out the way. Also, we have to make this until like a 0.17. So we're going to push them out. Let's see, is that a 0.13 right now? A 0.002, I think. So we make that 6 into an 8. That might actually be too big. But let's see, let's check it. No, it's a 0.17. Check me out. My math be mathing. Y'all ain't knowing. Y'all better ask about me. Ask about me, man. Shoot, I'm real out here in these streets. No, I'm just playing. Man, it's good to feel it though. 0.17 on that side and that side. 0.17 on this side. Now, when I did my printout, one of these holes was off. And I had to forcefully push it through there. So we don't have to worry about that now because we just fully cut those out. So we got that outer bracket there to hold it all together. Got the servo mount. Servo mount is going to be connected from the other side as well. It's exactly what we need it to be. If you wanted to make this bracket even more friendly to filament usage, you can cut it out this way, this direction too. You know, cut it out low or whatever, or cut a square out. Any kind of way you feel like you need to do it, you know, you could. That probably wouldn't be a bad idea though, to cut a square in there. Hmm. And this could possibly be done in two parts as well. It doesn't necessarily have to be mounted back to back bracket, you know. It could be something that mounts to each other so you can print easily. But then also it don't necessarily have to be connected, given that this top bracket here is going to be connected as a one solid piece. But that's something to think about though. All just depends on how long you want to wait for your printouts to happen, and whether or not that orientation of the part for print is best for you. Like if we make this solid, now the orientation has to be a certain kind of way, and then we have to print with supports. But if I leave it just like this, I can print from this bottom portion here, and it'll print upward, and I won't need any supports to get it printed. And it would have it would have what it needs. So that's something to think about. More yawns, excuse me. So that's what I wanted to get on here and tackle today. Just to get in there real quick, show y'all exactly what I did here and catch you up so that we don't be behind next time we go live. But I think that'll do it for now. We'll bring that body back so we can talk about it. Oh, that's the back. We have our donor wheels, which, man, the floor here is the bottom. At total bottom out, we have that at play. So we don't have to worry about this wheel here being moved up or whatever. That surface there is the actual bottom of the bottoming out. And then this whole setup can go up like a 0.2 more. So it's gonna have a really nice stance on it. And could possibly even have like a realistic looking stance on it when we finish with it. But that's what we wanted to do today. We have what we need in place. Like I was saying, if you have screws that aren't long enough to accommodate this whole movement and have room for that play where things aren't going to be binded, you can go ahead and extend that area out, add like a 0.1 to this, and get yourself a countersink hole so you can have so your screw can fit. That's just another thing to think about. But yeah, there she is, guys. We are one step closer to getting this thing on the road. All right. Well, thanks for tuning in. Please like, share, subscribe to the channel. Please hit that notification if you want to be notified when I am live. Also, keep designing. Keep designing, keep doing what you're doing. I drew a blank just a second there, but keep on, doing whatever it is that you do. Be motivated, be inspired by my work or by anybody else's work that do this stuff live and on the scene, on the spot for you. But keep it pushing. I love y'all. Stay up.